All right, so go ahead and get this in your notes. This is just a review of what we did last semester when we were dividing with exponents. So if you have the same base, you just subtract the exponents of the bases that are alike. All right, so you want to write each, I cannot talk, blah, start over. Write each base where the largest exponent appears. So if you have more x's in the top, you want to write the x in the top. If you started with more x's in the bottom, you want to write the x's in the bottom. And then we subtract the exponents. Okay? I always say think of where your leftovers need to be. Would your leftovers go in the top or would your leftovers go in the bottom? So this is an example of a monomial divided by a monomial. So one term on top, one term on the bottom. No plus signs, no minus signs. Just one term over one term. Now, where will my leftover A's go? Top or bottom? Bottom. You have 5 A's being multiplied on the top. You have 8 A's being multiplied on the bottom. You're going to end up with 3 leftover A's. They go on the bottom. So on the bottom, you'll have a to the third. Where are your leftover B's going? The top. How many leftover B's would you have? 22. So you have b to the 22nd over a to the third. Any questions? And we looked at this a little farther the first time around, but I'll refresh your memory. A to the 5th is like this, right? A to the 8th, 1, 2, 3, 4, 5, 6, 7, 8. And then any number over itself is a 1, right? So those are gone, those are gone, those are gone, those are gone, those are gone. We have 3 left over. They're in the bottom. Okay? So if you ever draw a blank on these, just start writing out what you know and see if you can come up with those rules on your own. A lot of times you can. It's a little easier to reason your way through it than to just straight up memorize the rules. So whatever works for you, go for it. I actually like writing these out. Sometimes it just takes me back to why we're actually doing what we're doing. But that's why. Okay? Questions?
So you want to leave the leftovers where the biggest X?
Yes, the leftovers go where you started with more. So I started with more A's on the bottom, so my leftovers go on the bottom. Thank you. Other questions? All right. Here's B. All right, now, students sometimes forget when you have coefficients in the front. Coefficients are just regular old numbers. So if I gave you 7 over 28, what would you do with that?
28 divided by 7.
Yeah, you'd simplify the fraction, right? You'd divide them both by 7. Somebody said it. It's 1/4. Okay? So don't forget your basic rules for simplifying with fractions. That would be 1/4. You might need the 1, you might not need the 1. It kind of depends how everything else simplifies. What about the A's? A's on the bottom, how many of them?
3.
Okay, good. What about the B's? Bottom, how many of them?
3.
Good. C's?
5 bottom.
How many of them?
1.
Good. So do we need the placeholder of the 1 in the top?
Yes.
We do. There's nothing else up there. So it turned out we did need the 1 of the 1/4. But let's say the A's were up top, you wouldn't need the 1. So it just kind of depends how it simplifies. What are your questions on this? And if you're thinking, we've already done this. We have already done this, okay? We just didn't call it a monomial divided by a monomial. We called it simplifying with exponents using division or something. Questions? Yes.
The same way as before with on the top. You have to put the 1 at the bottom.
No. So if everything cancels out from the bottom and you have a 1, you don't need that 1. Anything over 1 is just the whole number that was on the top. Tricky. All right, go ahead and write this one out. Okay, when you have parentheses and an exponent on the outside, do you guys remember what we do with this exponent? We multiply what?
All the other exponents.
All the exponents by this one, including the coefficient. So we have -1 in the front squared. What is -1 squared? +1. Okay, so that's why the negative is not written down here. Okay, because I had -1 squared. Then you just multiply the exponents. So a to the 4th to the 2nd is a to the 8th. B to the 12th to the 2nd is b to the 24th. C to the 3rd to the 2nd is c to the 6th. All right, on the bottom, a to the 5th to the 3rd is a to the 15th. B, put a little 1 there, to the 1st to the 3rd is b to the 3rd. C to the 2nd to the 3rd is c to the 6th. Everybody follow those steps. Now we can start doing the dividing of the exponents. But remember, when you're dividing with exponents, you're just subtracting the exponents with the like base. So where are my a's going to end up? Bottom, how many? Good, a to the 7th. Where are my b's going to end up? Top, how many?
21.
Very good. And C?
Cancel out.
Yeah, they're going to go away. Or if you do 6 minus 6, you get 0. C to the 0 is 1. Anything to the 0 power is the number 1. So yes, that's how they go away. Boom. What are your questions? All good? All right. Now we're going to find the missing factor. It's like a fill in the blank. Nope, this goes down on part A. I don't know why your notes have a D. Typo. You can just put an arrow if you started writing it by the D. I'm sorry. All right, so basically, what times -6 would give us 18?
-3.
Okay, good. And c to the what times c to the 4th would give us c to the 9th? 5th, very good. Okay? So -3c to the 5th. Or, if you want to write it out, technically we're just solving the equation. And the opposite of multiplying by -6c to the 4th is dividing by 6c to the 4th. So we kind of did it in our heads there, but this is the actual math behind what we did. So we subtract the exponents, c to the 5th. We divide the coefficients, -3. Okay? Yes, ma'am. Yes, you may. Any questions? So at first we just sort of reasoned our way through it, but this is the actual how do you do it. Just like solving an equation, okay? When you're undoing multiplying, you divide both sides by that coefficient, the -6c to the 4th. Any questions? All right, here's the next one. So again, what we're actually doing is asking ourselves, well, what would we multiply this guy by to make this? All right, and how do we undo multiplying? Divide. So we're actually going to go through and divide both sides by that 8x squared y. And then you can just simplify what you have over here. What is 16 divided by 8? 2. Good. X to the second, y to the very good. Or, like I said earlier, you can just do it piece by piece. Like, what's missing from the 8? Well, you'd have to multiply it by 2 to make a 16. We're missing 2 of the x's, and we're missing 2 y's. So, there you go. What are your questions? Next. All right, what should I do? Divide both sides by 11, x squared, y to the 4th. What is 55 divided by 11? 5. What is x to the 7th divided by x squared? X to the 5th. Y to the 5th divided by y to the 4th? Y. What are your questions? All right, anyone have any thoughts? Yes, sir. Whoa, wrong, sir. Sorry, this one. What did you do?
I multiplied 7 by 5.
Okay,
And
what
then-
about the M's and the N's and the P's?
Oh, I also put those together.
Okay, so what did you end up dividing both sides by?
Hold up. I only wrote down the answer I got.
Anyone know what we would divide both sides by? He is absolutely correct. You gotta multiply these first and then divide both sides by that. So it'd be
35 n squared p to the 5th.
very good. So we're dividing both sides by 35 mn squared p to the 5th. And this came from just multiplying these guys out. So 5 times 7 is the 35. N squared goes here. M goes here. And then p to the 1st, p to the 4th is p to the 5th. What is 105 divided by 35? 3. M squared over m. M. N to the 5th over n to the 2nd. N to the 3rd. P to the... I almost said the answer. P to the 10th over P to the 5th. P to the 5th. Phenomenal. Questions? Ready? Uh-oh. What's up? Sure. We're not about to do a super important challenging problem or anything.
Should we just write it right here? You don't have an E.
Now you don't have an E?
Yeah.
Why don't we put this one up where the last one was?
Just
Squeeze it in somewhere. All right, what do you think we should do? Yeah, let's take care of those exponents first. So up here, I'm taking everything to the fourth power. 2 to the fourth power is 16. X squared to the fourth power is x to the 8th. Y to the third to the fourth power is y to the 12th. Back here, x, oh, sorry, not to the x's yet. 2 to the first to the second is 2 to the second, which is 4. X to the first to the second is x squared. Y to the third to the sixth to the second is y to the sixth. Then what?
divide both sides by 4x squared y to the 6.
Very good. Divide both sides by 4x squared y to the 6th. And we get 4x to the 6th, y to the 6th. What are your questions? All right, now we're ready. Now, the first whole page of examples that you just finished, we had a monomial divided by a monomial, so no plus or minus signs. Here we have two terms. This is called a binomial divided by a monomial. When you divide a binomial by a monomial, you have to divide each term by that monomial. Okay? So this is like 16y divided by 2 minus 12 divided by 2. And sometimes you'll see this like divide. I do that a lot, but since this is a pre-made PowerPoint, when I click the next slide, that will go away. But you'll see that sometimes too, just to show that each guy gets divided by that 2. What is 16y divided by 2? 8y. What is 12 divided by 2? 6. So we have 8y minus 6. Can I make that 2y? No, why not? They're not like terms. One of them has a y, one of them does not. What are your questions? All right, next. All right, so what do you think I should do? Yes?
Divide 28p cubed by 7p and negative 35p by 7p.
Very good. You divide each of the terms in the top by 7p. Keep the minus sign. So what's 28p cubed divided by 7p? 4q minus 5. Perfect. Whoa. All right, same idea, and if you find it helpful, go through and do this. Woo, woo, woo. So we need to divide each of those terms by the negative 2x squared. I am keeping these signs for now in between the terms and keeping the negative with the 2. I'll clean up my signs at the end. All right, what is 4x to the 5th divided by negative 2x squared? Yes.
Negative 2x to the third.
Okay, so your first term is going to be negative 2x to the 3rd. What happens to that middle term? It's going to become a plus. So plus what? 12x y. What happens to the last term? It becomes a minus 5y squared. Good. Questions? All right, here's D. My foot hurts, I'm sorry. All right, once again, I will divide each of those terms by mn. My next step looks like this. All right, so what will my first term end up being? Good, 6m to the second minus 18mn. Then what? What's any number divided by itself? 1. You have to put the plus 1. It's not plus nothing. Plus nothing would be if we multiplied that by 0. We didn't do that, okay? You still have a 1 back there. It'd be the same thing as if we had like 3 divided by 3. That's 1. It's not nothing. Questions? Yikes. Yes.
So, what we just do? 4a minus 8 divided by 2, and then 15a plus 9 divided by 3.
Yep, divide each one individually and then see if you have some like terms. So we will do 4a divided by 2 minus 8 divided by 2 plus 15a divided by 3 plus 9 divided by 3. What's 4a divided by 2? 2a. Minus, what's 8 divided by 2? 4. Plus 5a plus 3. All right, what's 2a plus 5a? 7a. What's negative 4 plus 3? Negative 1. And then that's 6a, right? No. Those aren't like terms, so stop. I always think it's funny when it's like, keep the like terms separated, 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 and then boom, answer line, they just come back. I'm like, why'd you do the whole thing? Yeah. Anyway, don't go any farther. You are done. All right, what is 20x? Well, what should I do? Sorry, I started to say the next step.
Divide all of them.
Divide all of them? What do you mean?
Divide 20 and 15 by 5 and 30 and 10 by 2.
Very good. Now, you are subtracting this whole thing. So for now, I am going to put this in parentheses so I remember to distribute that minus, okay? Once again, you are subtracting the entire fraction. So I'm keeping it in parentheses so I remember, hey, this guy's a minus 2. Not TWO, TOO. All right, 20x divided by 5 is 4x. Minus 15y divided by 5 is 3y. As I simplified, I also distributed. So that's why this is a minus 15x and a minus 5y. All right, combine like terms. How many x's do I have?
2.
Yep, 2 spots where there are x's. So what's 4x minus 15x? Negative 11x. Don't forget, this is part of the 3y. So what's negative 3y minus 5y? Negative 8y. Perfect. That's it for today. What did we learn about?
Dividing monomials.
Dividing monomials. Good. All right, you finish those summaries up while I hand out your homework. We'll go over the homework tomorrow, and then we will continue on with Chapter 5.